Hi, everyone, and welcome to today's webinar, a guidebook to the AAMI's newest standard for flexible endoscope processing, sponsored by Healthmark. I'm Erica Carbajal, editor with Becker's Hospital Review. Before we start off the webinar today, I'm going to walk through just a quick few notes here. So first, we will start today's webinar with a presentation, and there will be time at the end of the hour for a question and answer session. You can go ahead and submit any questions you have throughout the webinar by typing them into that Q&A box you should see on the right side of your screen. The session will also be recorded, so it will be available after the event, and you can go ahead and use the same link you used to log into today's webinar to access that recording once it's available. And if at any time you don't see your slides moving, or if you're having any audio or video issues, just try refreshing your browser. You can go ahead and use that same Q&A box for any technical questions as well. We're here to help on the back end with those. So with that, I'm pleased to introduce today's speakers. We're joined by Marianne Droznak, Director of Clinical Affairs at Healthmark, and John Whalen, Clinical Education Specialist at Healthmark. So I'll go ahead and turn the floor over to you, Marianne.
Thank you so much, and welcome everyone. I'm glad that you could join us here today for this presentation on the newest standard, ST91, for flexible endoscope processing from AAMI. So let's go ahead and get started with some introductions. I'm Marianne Droznak, and as I said, I'm the director here of clinical affairs at Healthmark. And my background, I have over 20 years in the role of healthcare. I've been with Healthmark in the role of education for nearly 7 years. Prior to that, I worked for Olympus America as the manager of infection prevention for endoscopes and surgical equipment for the U.S., Canada, and Latin America. And before that, I spent 10 years in pharmaceutical microbiology. I was the co-chair of AAMI Working Group 84, which was responsible for writing the ST91 document from its very beginning. We joined the committee, started in 2012 and officially launched in 2013. The first edition went live in 2015, and we had been working on this update ever since. So with the completion of this document and approval in late 2021, my role as co-chair of the working group is over. It's long overdue. So now I will become a member of the committee and pass that co-chair role on to someone else. So I'll stay involved, but in a different role now. I also continue my professional memberships, AAMI, AORN, APIC, ASGE, SGNA, very heavily involved in AAMI and APIC because, as you can see from my certifications, I do have that specialty in infection prevention as well as being fellows of AAMI and APIC. So with that, I'm going to pass it off to John for an introduction to his background and then also to kick off the webinar. Go ahead, John.
Thanks, Marianne, and thank you very much to Becker's for this opportunity. I appreciate everybody joining us today. I'm John Whalen. I'm a registered nurse. I've been in healthcare over 40 years. As a nurse, my career has been predominantly in emergency and endoscopy. I worked 20 years in endoscopy as staff, then educator, then 15 years as a clinical manager. I spent my last 4 clinical years overseeing high-level disinfection and endoscope processing for our academic health system. I've been with Healthmark now for 3 years as an educator. I've been a member of SGNA for many years, currently sit on one of their editorial advisory committees. Additionally, I'm a committee member of the AAMI work groups for endoscope processing and chemical sterilants. Next slide, please. So these are our disclosures. We are employees of Healthmark, which is a manufacturer and distributor of medical products. We've not received compensation for this presentation. Any opinions that are expressed here today are ours. The program's not intended to serve as either a training guide or a promotion. And we always stress, before using any medical device, always read and follow the manufacturer's instructions. Next slide. It's the mission and policy at Healthmark that we provide customers and the healthcare community with not only high quality and state-of-the-art medical products and support services, but just the very existence of the clinical affairs and education team at Healthmark and the gratis support that we provide, I think are really further evidence of the company's true commitment to educating our customers and the public. Next slide. These are the objectives for today. We'll discuss the updated national standard that is ANSI AAMI ST91, highlighting key differences between the previous 2015 version and the latest update. We'll identify current best practices in the processing of flexible endoscopes as outlined in that document and other guidelines. And we'll learn how to review the standard and evaluate areas of non-compliance. Next slide. So what are expected cleaning and disinfection and sterilization practices based on? Well, they should be based on manufacturer's instructions for use, or IFUs, standards and guidelines, and your own written policies. So which organizations do you follow? Which organizations should you follow? Next slide. In the United States, there's mandatory regulations as well as voluntary standards and guidelines. You see here on the right of the screen examples of common reference organizations. So starting from the top down, in the U.S., we're legally obligated to follow OSHA and EPA. When it comes to the FDA and the CDC, you'd really be hard-pressed to justify not following guidance from them. Then we get into standards and guidelines from professional societies and standards organizations like AAMI, ASGE, SGNA, and AORN. And then accreditation and surveying agencies, you see two examples on the bottom of the screen here, Joint Commission and AAAHC. Use all the above as reference points. So it really depends on your organization, for example, your hospital, your health system, to identify by written policy who and what you hold your staff accountable to. Next slide. To provide an example of how processing standards influence related policies and how both influence external accreditation surveying, let's consider AAMI standards. Standards are performance-based documents that assist the healthcare industry with performance, use, acceptance, and advancement criteria. Standards like ST91 may also be user-oriented to promote the safe use, application, and maintenance of health technology. The use of standards is voluntary. Policies should be based on current best practice standards. So when you reference given standards in your policies, accrediting surveyors will then audit to those standards and your policies. Next slide. For the organizations and documents that direct processing of reusable medical devices, these are the common foundational threads. This continues to be a work in progress. The good news is that little by little, the major organizations that produce the standards and guidelines are coming together on key content, especially related to, as you see, quality control and evidence-based practice recommendations. The real benefit then to the frontline customer is that the various guidelines are more complementary than they've been in the past. That's not to say that different interpretations and recommendations don't still exist. Now to you, Marianne.
Thanks, John. And I was looking at the chat, and I'd like to address the so-called elephant in the room based on what I see in there about the paper that came out from the Joint GI Societies. And although we can't say too much about it at this point in time, that does exist. I do say that those professional societies sat on the working group and were involved in the process. And I have been told that other societies will be hopefully writing a joint statement then in reaction to the statement from the Joint GI Society. So we'll see where all this ends up. But remembering this is a national standard that has been voted on and approved by not only the working group, but the AAMI Standards Board and the ANSI Standards Boards. And anybody on that committee has a vote, and they have a right to vote negative on that. And everything was done according to AAMI policy. So we ended up with this as our national standard, which I've been very proud of. And it has great information in it. It has really solid recommendations and requirements that are based on science. We have all the citations in there to support the changes, to support the requirements. So it will be up to your healthcare facility to determine what level of implementation for these new standards go. It is up to your facility to determine what is your policy, what guideline you're following, whether it be ST91, knowing that it is a national standard, or whether it be SG&A. That is up to your facility to determine what to implement, and hopefully we work this out going forward. But for now, that's where we lie with that statement. All right, so let's go ahead and get started on ST91. So we did see in March, particularly March 3rd of this year, the new ST91 was released. And I just want to clear up any confusion around the dates as far as they're concerned. It does have a 2021 date on it for its issuance. And that's because we as a working group had worked on this for many years. And then middle year last year toward fall, we ended up taking it to a final draft and voting for approval on it. And it was approved by the document. We did have some negative votes, but we had more than was necessary to move forward than the document. Remember, these are consensus standards, so you have to have a certain number of positive votes based on the number of people on the committee in order to move forward. You don't have to change any negative votes. You just have to try to work through them to get them to an agreement point. But if that's not possible and you still have the correct number of votes or more, you can move on. So we did that in late 2021, and then it was approved by the AAMI Standards Board and the ANSI Standards Board at the very end of 2021. So that's why this new document has the 2021 date on it, even though it was released in 2022. In that meantime, we had the holidays. It went through copy editing and ready for release, so there was a lot of work going on in the background. But so we do have the 2022 release date, even though the standard date is 2021. We also, as a committee, are currently working on another document. This is TIR 99, which is a technical information report, and that's on the processing of probes and dilators. So we're on working draft 2 now, resolving those comments. I believe it'll go to a third working draft, which we should hopefully be able to get through a resolution of comments in October. So I am saying either very late 2022, which I actually doubt, but more likely 2023 for the issuance of this informational report on probes and dilators processing, which I think would be very well received in industry. As an overview, I wanted to talk about some high-level changes that you'll find within ST91 before we really delve into the nitty-gritty of it. So we've paid a lot of attention to detail in wording within this document, and by that I mean we carefully debated whether our guidance would be a should or a shall, and as you'll hear in a few slides, those have different meaning as far as what your action needs to be related to that guidance. So really a lot more detail spent on that. Inclusion of peer-reviewed research and FDA MOD database citations. As I said, this is a much more comprehensive document with many new recommendations and requirements in it, or strengthened wording around a specific topic. So in order for you to have the support and the information needed to implement those changes in your facility, we wanted to make sure that you had as much evidence there to show leadership why this needs to be done. So we've included that as peer-reviewed research citations, and new this time is we included FDA MOD database citations, because most facilities don't have the time or really want to dive into what's reported to the FDA in those safety alerts, those safety reports. So we did that, and if we found a citation that really matched what our other evidence was saying, and also supported the recommendation or requirement that we were making, then we did include that, which was new. We do re-emphasize certification and put a little more wording around that and how we expect certification or recommend certification for anyone processing scopes and what's required for training and competencies. We included more information on the direction or physical design of the processing area for endoscopes, requiring that unidirectional flow. We have a new term, high-risk endoscopes, which we'll talk about, and management of that new type of scope. Not a new type of scope, but a new classification for those that are considered high risk or are more often associated with outbreaks, have a more complex design, generally harder to reprocess. We're now terming those high-risk endoscopes. We have retermed what we formerly called pre-cleaning, or what's done immediately after the patient procedure, to the point-of-use treatment, and we'll explain why. Much updated sections on inspection, including enhanced visual inspection with lighted magnification, cleaning verification, boroscope inspection. We take a strong recommendation against doing any manual disinfection processes except in emergency situations. A much expanded section on drying after reprocessing, including those scopes that are coming out of an AER and those that are going back into immediate reuse. We have more information around clean handling, wearing gloves, containerizing scopes, what to do in storage. We've embedded how to monitor quality throughout the document. Much expanded emphasis and section on sterilization, as this is where we see the future of endoscope processing, and have included many appendices or annexes which give you just information on the topic, such as inspection. We have a very informative pictorial annex on inspection, including internal boroscope inspections. As I alluded to earlier, words have specific meaning within standards documents, particularly with AAMI, and I think it's always helpful to learn what these are or review them, because when you get the document and you start digesting it, you really want to look at what the action word is associated with that recommendation or requirement, and that helps steer your course of action. Is it a must that we say that? If it's a must, then it means you have to do that. It is above and beyond the standard. It is considered an unavoidable situation, such as those mandated by governmental regulations. Mainly we see these related to OSHA regulations in the areas of bloodborne pathogen training, contaminated or sharp instrumentation, transportation, requirements for wearing PPE. Those are all captured within the standard as a must. So know that whether or not you're claiming compliance to that standard, that is something you have to do, or you're subjected to OSHA law for that. A shall then is your highest tier per the standard, right? Must above and beyond it. A shall is a requirement of the standard. So if your facility is claiming compliance to ST91, then that is something you have to do. It is a requirement of the standard. And as John said, although the AAMI standards are voluntary, if you are claiming compliance as a facility or a system, then that is expected that you will do that. A should is your next tier down, and that is a strong recommendation, but that may be one possible way of doing it, and there may be others. So really, you should be doing something on that topic, but it may not be exactly as we've laid it out. It doesn't really mean that you should say, oh, that's just a recommendation, I don't have to do anything for it. We would really recommend then that you evaluate that topic. You might want to create an interdisciplinary team to look at what exactly that is and how does it fit best into your facility, and what can you do to comply with that. Next down, then you have a may, which just means that course of action is permissible. So it's something that the standard gives you permission to do if you're able to. Whereas then you have a can, which just means that topic, or doing that topic, is possible, or you might have the capability of doing that. So again, as we've said, we've really put much more emphasis on making sure we get the right words for what we need. So help use those in your evaluation of the standard. As I said, we've included many more citations, a lot of additional peer-reviewed literature that's gone in to support the changes that we've made so that you see why we've made those changes, and also to give you the support that you need to make your changes in your facility, writing your new policy, adding in those citations so that you have that data to support why you need new equipment or why you need more time to do this step. It's all there for you. And we've included those citations from the MOD database, which you see on the screen. It's the Manufacturer and User Facility Device Experience. This is regulated by the FDA, and this is a requirement that manufacturers and facilities put any adverse safety, major safety events in here, major injuries, deaths. You'll see all of that reported in here by type of device, manufacturer, however you search, it's publicly available data. And also, within there, we thought it very important to make sure that people become familiar with this. And so that's why I have this screenshot on here today that you can go in there and see if you want to look around and see what kind of reports come in for the devices that you're using in your area. It may be eye-opening to you to see things like, not only these serious infection outbreaks, cross-contaminations, but instances of devices that are damaged, significantly damaged, that the facility wasn't inspecting them and they were used on a patient, and then the patient got harmed, significantly injured during the procedure because a malfunctioning or damaged endoscope was used on them. So that's all there for your publicly available information to review. So take advantage of that. But we know you're short on time in facilities, and that's why we went through and included those citations within the document as support. So a little more information on here. As I said, the MOD database, it's mandatory for manufacturers, imported device user facilities to input their adverse event, their significant adverse events such as serious injury and damage in here. It's also voluntary for healthcare professionals, patients, and consumers. And sometimes you do see patients upload their adverse events into this database. So it's got at least the last 10 years worth of data in there. It's a lot. It really is a lot to take in and a lot to get used to when you're looking through it. And again, that supports why we added those citations into the next ST91. All right, let's start out with some recommendations within ST91. We do see in there, we've had recommendations for certification back to the 2015 version, and we maintain that, saying that processing personnel should be certified within 2 years of employment and maintain that certification throughout their employment. So basically, that means it should be written into their job description, an expectation when they're hired that they do attain that certification within 2 years. Of course, if your state has anything that's stricter than that, then you would want to follow that. But some states don't have any requirements or recommendations for certification of technicians. So we wanted to make sure we address that. Education, training, and competencies, we do state that prior to doing anything on their own, anyone that's processing endoscopes needs to have this education, training, and competency completed before they do any independent work of processing those endoscopes. You do that initially, of course, and then at least annually, as we do with our other trainings. We want to make sure that we include the whole gamut of trainings that we would expect in endoscopy, anything from standard precautions, bloodborne pathogens, hand hygiene, all the different models of scopes, training on each specific one, our AERs, that's the automated endoscope reprocessors, any sterilizers, all of that need to be included as part of the training program for any staff that is processing endoscopes. Another topic that's important for endoscope processing is the design of the processing areas. And historically, endoscope processing areas have been very small and were maybe last on the list to get the space that they needed. But we truly need enough space and enough time and the proper equipment to do this right. If you look at that MOD database and you look at the latest things that have just come out from the FDA about processing of endoscopes and moving to duodenoscopes with single-use design or single-use caps, and what the true rate of culture positives are for processed duodenoscopes, we see that we still have a problem. And although we do see that pushback from some organizations of adding in these quality steps, it is adding in quality. It is mitigating safety issues for our patients. The things that we're asking in the standard to do, like cleaning verification tests, we've always asked for cleaning verification tests. There is a lot of data out there to support doing those. The same thing with inspection. We know, based on the studies that have been done, there's a lot of data to support external inspection. There's data now to support internal inspection with a borescope. That's all why all of that is in this new standard. The same applies to the design of the processing area. We know we have to do better with our facilities area for endoscope processing. We can't let our clean and dirty areas be right next to each other. And I see this happen all the time when I go in to audit facilities, that they're their decontam sink where they're brushing the endoscopes is right next to the AER. That's not okay. We need sufficient space and sufficient design of the endoprocessing area, because there are studies out there that show that our aerosols go 4 feet at least, and greater than that in some recent studies, up to 6 feet or more with the aerosols that we create when we're doing our brushing and flushing of these scopes. So we need that separation and a large enough room. We want to make sure we have unidirectional flow from dirty to clean for endoscopes. We do prefer a 2-room design. In the standard, we say that to separate those processes, it is preferred that you have 2 distinct separate areas. We know that's not possible today, but we want to move the industry to that because we do have data to support that change. So how do we do that? Well, in the meantime, if you can't have a 2-room design, you make sure you have that unidirectional flow, and you make sure that you, as maybe your infection preventionist, can come in and really look at or audit what's going on in that facility. We want to have a designated drying area. We want to make sure our storage area is separate. Traffic is restricted. For our sinks to manually clean the scope, ideally it should be 2, preferably 3 separate sinks. 1 for leak testing, 1 for manual cleaning, and 1 for rinsing. But if not, if you can't have 3 sinks, ideally we'll move to that. If not, if it has to be 2, you do 1 leak testing and manual cleaning, and 1 only your rinsing. We need to make sure we have instrument air, compressed air available with a regulator, and you also have to think about, do I have proper space requirements? Do I have enough to do this cleaning? Do I have somewhere that I can put the scope to do an inspection on it and a cleaning verification? If not, use the standard to make the changes that are necessary while having that support. With that, John, I'm going to turn it over to you.
Thanks, Marianne. So a significant declaration in the new ST91 is a definition for high-risk endoscopes. That means those that are associated, have been associated with infectious outbreaks, and those that are difficult to process. So what that includes are elevator channel endoscopes, so duodenoscopes and linear EUS scopes, as well as bronchoscopes, cystoscopes, ureteroscopes, and endobronchial ultrasound or EBA scopes. It also would include others as determined by facility. So what's an example of that? Say that you're a facility that does endoscopy procedures on pre and post-transplant patients, obviously high-risk patients, or say that you're a pediatric facility and you choose to have the scopes that are used on pediatric patients listed within your organization as high-risk endoscopes. Then you pay attention to those and treat those as high-risk endoscopes when it comes to cleaning verification testing. For one, ST91 states that high-risk endoscopes should undergo cleaning verification testing every time they're processed. Also, high-risk endoscopes should receive prioritization for any risk assessments that are done, and we'll talk a little bit more about that. Next slide, please. So let's address the revised ST91 by looking at the standard workflow for endoscope processing by high-level disinfection or sterilization. We're going to reference new content and emphasis, as well as current best practice recommendations. Next slide, please. The term point-of-use treatment is now being used to represent all the tasks that are required immediately after the endoscopy procedure in the procedure room. So yes, it includes pre-cleaning, and most people had just referred to this as pre-cleaning in the past. But it also includes removal of accessories, preparation for transport, and communication for processing staff. In point-of-use treatment, and specifically in pre-cleaning, it's that initial removal of organic material that's critical to the steps that follow to decrease the bioburden load for all the subsequent steps. So pre-cleaning matters. It has to happen every time, and it needs to happen right after the procedure in the procedure room, regardless of who's taking the scope to be processed or where the processing room is. Doesn't matter if it's right next door or across the hall. Pre-cleaning always occurs. And time is critical, and this is emphasized multiple times within the document. We need to limit bioburden before it has a chance to dry. Also, biofilm only takes minutes to develop. IFUs and guidelines call for the use of non-linting cloths or sponges to be used in point-of-use treatment pre-cleaning. And then we emphasize the need for handoff communication from point of use to the decontamination area, and that minimally should include patient identifier, date of procedure, and time that point of use treatment was completed. Next slide, please. The need to pay attention to delayed processing protocols is emphasized, as I mentioned. At this stage, it refers to the time frame between pre-cleaning at the bedside and manual cleaning in the processing area. Currently, the most prescriptive direction related to delayed processing comes from Olympus. Most significant here is that the additional detergent soak that is delayed processing can be up to 1 hour, up to 10 hours. It really depends on the model of the scope. So it's important to reference your endoscope manufacturer's written guidance for delayed processing. So we've pre-cleaned, we treated the scope at the point of use. Now we're transporting soil to the processing area. Direction is given to keeping scopes moist for transport. Examples of that would be applying a pretreatment solution or placing a towel moistened with water over the scope, or placing the scope inside a package that is designed to maintain humid conditions. OSHA regulations are reinforced. They direct the need for and the type of containment. Next slide, please. So now the scope's made its way to the processing area. The first task here is leak testing, and that needs to happen every time. Leak testing has to be performed every time a scope is processed before it's manually cleaned. It's the opportunity to prevent not just fluid invasion inside the scope, but bioburden invasion as well. The key here is following every step of not only the endoscope, but the leak tester manufacturer's IFUs, and then removing a scope from clinical use when a leak is detected, regardless of how large or small the leak is perceived to be. Emphasis is given in this new document related to daily QC testing and documentation of pressure outputs from leak testers. Because if the leak tester is not supplying adequate pressure, leaks can be missed. Next slide, please. So manual cleaning is next, and it's still emphasized, as it has been for years, as the most important part of processing. For the manual cleaning performed at the sink, reinforcement is given, as we mentioned, to delayed processing principles, having utility water rinse after detergent wash. Utility water would be tap water rinse. And this is, again, following detergent wash. Then drying the exterior with a clean, non-linting cloth and purging any accessible channels with instrument air or filtered air from a flushing pump. This throws a lot of people. Why would I dry a scope, especially if I'm just putting it in an AER next? Well, you're not. What you should be doing next is a step called inspection that we'll talk about in the next slide. And you can't see through water, so we need to dry the scope and the channels to be able to adequately inspect it. For automated cleaning, that is use of AERs, recognition is given that some current generation AERs do have cleaning cycles that are validated and FDA cleared, but emphasis is that automated cleaning cycles don't replace or abbreviate point of use treatment, for one. And if considering replacing full manual cleaning with automated cleaning, you should convene a multidisciplinary team to conduct a risk assessment so that you're all on the same page and agree that that's the right thing to do. And then the reason that we have on the lower right of the screen the reference to the FDA document, when it comes to duodenoscopes, the FDA recommendations are reinforced within ST91, that AER cleaning cycles are only a supplement to thorough manual cleaning. Again, that's duodenoscopes. That FDA reference document is shown here. Next slide, please. As I mentioned, inspection follows manual cleaning as a unique, purposeful step in the process to better ensure that manual cleaning was as effective as possible. It's intended to be its own step, a timeout, if you will. It can include cleaning verification testing, and it can also include boroscopic inspection. Basic visual inspection with the unaided eye, simply looking at the scope, is the minimum standard for cleaning assessment. In the updates to ST91, enhanced visual inspection, which means lighted magnification, is promoted, with emphasis that the scope needs to be dried first. Still, it's impossible, simply by looking, even with magnification and light, to completely determine cleaning adequacy. So we consider the use of cleaning monitors that are also known as cleaning verification tests. Reinforced is sending scopes for repair that repeatedly fail cleaning verification tests or have damage. Directions given to use of cleaning verification testing, as we mentioned, for all high-risk endoscopes. That's those that have been determined to have issues, as well as those that are determined by facility to be in the category of high-risk endoscope. Borescopic use is presented as a possible supplement to enhanced inspection, especially for channeled endoscopes and distal tips and valve openings. Next slide, please. For manual rinsing, the use of critical water for the final rinse unless sterile water is specified by the manufacturer's written IFU. There's focused recommendations against manual disinfection. This is a statement that is clearly stated a few different times in the document. We do give manual guidance because there needs to be a manual backup if automated processes fail, but automated processing is always promoted. There's reference to AER flow QC testing as per AER manufacturer's instructions. There's direction that scopes left in AERs for more than an hour should undergo repeat HLD cycles. Again, we pointed out that biofilm only takes minutes to develop. The AER is a moist environment, and so scopes should not be left overnight for sure, but even more than an hour inside an AER without going through a repeat HLD cycle. And also reinforced at this stage is we need to be paying attention to the PPE that we were wearing for decontamination. It should not be the same PPE when we go to remove scopes from an AER. We should have clean PPE on because these are now close to being patient-ready scopes. We also talked to critical water in the manual processing phase, and critical water refers to deionized water and reverse osmosis. Next slide, please. Talking further about water quality, studies have identified endoscopes contaminated with bacteria, including waterborne pathogens, following high-level disinfection, despite adherence to processing guidelines. So the water that's used to rinse disinfected endoscopes was implicated in these cases. So as part of water management plans, there should be periodic microbial assessment of the AER and processing equipment. That should be considered to identify water contaminants or contaminated equipment, which could contribute to recontamination of a device that's already been high-level disinfected. Also, periodic microbial assessment of the water itself that's used for final rinsing should be considered. So where this is really important to pay attention to for administration as well as facilities and infection preventionists, construction, renovation, and repairs should result in quality testing for downstream automated systems. And whenever endoscope reprocessing failures are identified, water quality testing should be part of that standard follow-up. Next slide, please. So drying post-processing receives considerable attention in this new version of ST91. Scopes must be completely dry before they go into storage or they're used again clinically. So the bottom line here is before they leave the processing area, their scopes are dried, in addition to whatever happened in an automated process. So following manual or AER cycles, we follow with active air drying. Remember, the cycle in an AER is only a purge of air. The guidance here is a minimum of 10 minutes with pressure regulated, forced instrument air or a minimum of HEPA filtered air. And then we need to consider quality control for drying. How can you know that the scope is dry enough? Well, options are here. You could, with a channel endoscope, you could look with a borescope, or you can even look at distal surfaces, distal tips with borescopes. But there's also drying verification tests that exist. There's a detailed, informative annex on drying in this new version of the standard as well. Back to you, Marianne.
Thanks for that, John. Let's move on then to storage of endoscopes and clean handling. We did stop short of requiring any sort of drying cabinet. We do prefer them, but we know that that's not feasible in a lot of facilities that already have traditional cabinets or can't have them retrofitted. So drying cabinets where the airflow is hooked up to the channels directly and includes that circulating air through the channels is one way to achieve drying of your endoscopes, but not the only way. At minimum, we need that HEPA filtered air circulating through the cabinet itself around the endoscopes. Instrument quality air is preferred, but at minimum HEPA. And as John said with the drying, one way to do that is a drying cabinet. Others are drying pumps, or retrofitting your cabinet to be a drying type device would be another way to do that. We do have within ST91 that we don't want any endoscope storage within the procedure room or processing room. And I often see this happening in your surgery centers where they'll have a storage cabinet within the procedure room. That has not been recommended historically, and we continue to stress that you want to get those cabinets out of the procedure room. They should be in a clean storage area. We do stress that anytime you handle endoscopes, you should have gloves on. And the same applies to when you're handling processed clean endoscopes. We do recommend hand hygiene and donning clean gloves for that handling step. So when the item comes out of the AER, you have the clean PPE on, the technician taking it out of the AER, doing those drying steps, and then putting it into the drying cabinet. We also want those gloved hands coming into the room, taking out of the storage cabinet, and then putting that in a container to go back to the back to the procedure room. So we do want that containerized there unless it's in a controlled connected corridor is what the standard says. Then you do have a little more leeway of not containerizing that to make sure that it's protected physically from damage in the environment. But we do, in most circumstances, want that containerized. We did keep the recommendations in to keep the valves together as a unique set, but we've given many more recommendations as to how you might be able to comply with that, because we did have a lot of questions and even some pushback on that recommendation. But it is important, if you're still using reusable valves, which not a lot of facilities are anymore, that you somehow have them traceable to the patient and the procedure. So more information in there on that. We do still recommend a distinct visual cue be placed on the endoscope in the storage cabinet so that anyone knows by looking at it that it has been processed and is patient ready. So however you choose to do that with a tag would be fine then. As far as hang time goes, or how long a scope can hang in the cabinet before it has to be reprocessed again prior to use, we stuck with our original recommendations, which is a multidisciplinary risk assessment should be performed. And within ST91, we have a lot of information in a chart there to help you walk through what the questions are that you would ask as part of that risk assessment. Because if you think about it, if you're doing everything right per the IFUs, you're adding in these quality measures through adoption of the standard, you're doing that inspection and cleaning verification, you're putting it through an AER, you're doing all of the steps of drying externally and internally with the compressed air drying, you're handling with clean gloves in a cabinet that's remaining closed, then why would we only get 7 days as an example? So that's really up to your facility to walk through. You may be able to get longer storage, or if you have poor practices, you may not be able to get any length of storage on it. So we really wanted to leave that up to the facility to determine what the proper length of storage is for your facility. We kept in recommendations for monitoring the manual cleaning process. So if you have an AER that has an automated cleaning process, you would check that periodically to show that you're in control of that situation. that you're monitoring your manual cleaning. You do that with cleaning verification testing. We have more information on loaner scopes and what to do with those coming in and out for repair and making sure we're monitoring those. Very helpful to take borescope pictures or photos for those that you see your repairs have been done or what's going out. We do ask that you create a multidisciplinary team that looks at quality assurance and safety and implementing that program in your facility. Information in there on risk assessments and when you would want to do that. Continue the information on proper documentation and record keeping, and of course that what to do when you're sending out repaired and loaned devices. Okay, so this slide highlights some common weak points or lapses that occur within the reprocessing of scopes. On the right, you have the high-level disinfection, and we can see things go wrong at all steps in the process, which is why we have recommended and in certain cases required these verification steps, cleaning, verification, and inspection, because that helps you ensure that your manual cleaning and your rinsing was done adequately. For leak testing, we've now recommended that you verify that your leak tester is working properly, because we've seen many instances where even though the leak tester is putting out the proper sound, or it sounds like it's working, that it's either not putting out the right amount of pressure or no pressure at all. So that's why we've added in the verification of that step daily. Every time that it's used, it takes 30 seconds maybe to verify that your leak tester is working properly. We have breakdowns that occur, especially with manual high-level disinfection, why we now recommend the automated. Drying, we talked about drying and looking at making sure that we're either putting the scope into a drying cabinet or we're flushing with the 10 minutes of compressed air, minimum HEPA filtered quality air to dry those endoscopes. And the document does say that if you're doing a manual drying process, like using a drying pump, that you should, so it's a recommendation, periodically do a drying indicator test on it. That shows that your drying process is under control. It's all about quality parameters and demonstrating that your process remains under control, because historically we've had very little in the way of feedback mechanisms for high-level disinfection. Storage, now we're talking about breakdown of keeping the storage cabinet clean on a regular rotation, making sure the door is closed, making sure that we're using gloved hands, all breakdown points that we can have within the high-level disinfection. But remembering if and when we transition to sterilization, then we have to add in that drying step. After we've done our manual cleaning and rinsing, cleaning, verification, and inspection, we move on to drying. That is a new step that would be added because we don't want to sterilize a wet instrument. So then we have to add in that drying before we package for sterilization and so forth. So we highlight this because, as I said earlier, we know that issues can and do occur related to scopes. Infections continue to be reported, although we don't hear about it in the news as often as we used to. If you look in that FDA database, you'll see that it can and does occur, and more frequently than we ever thought. And with all models of endoscopes, it's not purely a duodenoscope issue or a bronchoscope issue, although those may be the most frequent ones. We see often ureteroscopes, you can see gastroscopes, colonoscopes, all of them. So we need to continue to have this quality mind frame and doing more with our endoscopes to make sure that we're having high quality processes. So this was just one report that we highlighted back from 2016 where we had 6 patients infected with E. coli, and 2 of them unfortunately did die from that. And when they inspected the scopes with a borescope, they found big scrape marks, brown stains, all of that in the suction channel and the biopsy channel area. And when the leak testing was done, they confirmed that there was glue missing. So the scope was in really bad condition to begin with and used on patients. And that's why we stress, as does SGNA, they do stress this inspection step, looking at least externally as your safety step, your timeout to make sure that everything looks in good condition. We don't see repair issues or debris left on that scope. Next slide then, talking more about quality control. So where do we need to add that quality control in per the standard? So we have on the bottom right highlighted the cleaning verification. We discussed that. It's a shall for all your high-risk scopes every time a should for your non-high-risk scopes at a statistically significant portion of those cycles that they go through. We want to add in that inspection, at least externally with lighted magnification. You may want to add a borescope in for a periodic internal inspection. Yes, best practice would be doing every procedure every time, but we did not require that. We just recommend the borescope periodically. And then adding in the drying. We've got to think about then verifying that our drying practice is working properly. And if we're doing it manually, that we periodically use a drying monitor. There are several different kinds of those on the market. Or you can use a borescope to check your endoscopes in storage to see that there's no water in them. That's an easy way to verify that your drying practices are working. So periodically you would do that. And what about surveillance testing? That's another important topic to look at, and we're going to talk about in just a minute here. But how do we know that even though we've gone through everything with this endoscope, how do we know that we still don't have contamination in that endoscope? Well, we stopped short of requiring microbial surveillance. We do recommend it as part of an overall quality control plan that periodically you might want to culture your endoscopes through either traditional culturing or a more rapid gram-negative test kit to demonstrate that you don't have active contamination, at least that the kit can pick up within your endoscopes. So it is, some facilities do this routinely, others do not. Of course, you would do that in the event of an outbreak, but what about under routine circumstances for your duodenoscopes, those that are high risk? What are you doing for them, since the FDA does recommend that you do more with your duodenoscopes, and culturing is one of the examples that they give for that. So again, it's voluntary but can be part of a quality control, so you need to evaluate that in your facility and see, do we need to do microbial surveillance cultures of our endoscopes, particularly our duodenoscopes, or are we okay? I want to stress this is not ATP testing or cleaning verification tests. Those are used after cleaning. Microbial surveillance is used after the process is complete. There are also, as I said, gram-negative, more rapid test kits that just look for organisms like E. coli, Pseudomonas, Klebsiella, all of that. Now, I do want to stress that as a group, we felt that we should be moving to sterilization, and we decided to re-stress the original Spalding classification system that said that your endoscopes are semi-critical devices that need to be cleaned and should be sterilized. So in routine circumstances, even our endoscopes should be sterilized. And then we said if that's not physically, original Spalding classification said, if that's not possible, feasible, then we resort to high-level disinfection. But as an industry, we have come to accept high-level disinfection as the main standard of care. So we want to re-stress that we do need to move to sterilization and get the industry there over time. So although we didn't require it, we felt important to re-stress that and figure out how we can transition from high-level disinfection to sterilization. So all scopes that are used in critical applications, so sterile parts of the body, must be sterilized. If they're used in semi-critical applications, so normally touching the mucous membranes, then they should be sterilized. But if that's not possible, then we high-level disinfect. So we know that the industry has to catch up for a little while. We need scopes with better compatibility for sterilization. We need more sterilization modalities and FDA clearances for those that do exist already. So this is going to be a moving target over time. And so what I recommend for facilities is that you take an inventory of your endoscopes, know what you have already, and based on the Spalding classification, which is what the FDA accepts, move anything that already can be sterilized to sterilization. Your low-hanging fruit, attack that first. Those are your scopes like your bronchoscopes. They have been compatible with low-temperature vaporized hydrogen peroxide systems and ETO for years. Going back to 12, 13 years, they've already been compatible. So if you have a bronchoscope and you have the ability to run that in example STERRAD or VPRO systems in your hospital, then why aren't you doing that? It's a high-risk scope. It's a very sick patient population. We should be sterilizing those. So that's one of the first things I look at when I come in to audit facilities. What are you doing with your bronchs? Why aren't they being sterilized when you have that available in Central Sterile Services, or SPD. And I know we don't like to lose control of our inventory, but sometimes that's necessary. If you are moving to sterilization, we absolutely have to inspect those during the processing cycle and also, again, in the procedure room before they're used per the IFU. We still need to focus on adequate cleaning and drying and preparation and inspection. That doesn't go away because we've moved to sterilization. But what's great about sterilization is we get a wrapped item that can lay flat in its wrap per your hospital facility. So we don't have to process them as often. So this I've already touched on. Know your inventory. Look at the compatibility of your scopes. Move anything like your bronchs, your readeroscopes should already be sterile. We saw a safety alert come out this week on certain urology scopes. Cysto, hystero, ENT, a lot of those can be sterilized, so they should be sterilized. Beyond that, prioritize by risk. What's high risk? Figure out what you're going to do with that. Example, your duodenoscopes. Then go based on the FDA recommendations to do something. Sterilize them, culture them, liquid chemical sterilization, move to disposable scopes or disposable end caps. All options for you. And then lastly for me, as John and I said earlier, we have a lot of information in annexes or appendices to ST91. You'll see that list here. I'm not going to go through them, but a lot of great information on those topics, whether it be simethicone, we have that pictorial annex for visual inspection, all great information there. No requirements in annexes, just information for you to review. So with that, John, I'll turn it over to you to end the presentation. And thank you, everyone.
Thanks, Marianne. So we can mitigate and or remove risk by standardizing processes. That's something that we need to look at system-wide, and thus we limit deviation from best and expected practices. Also, we can mitigate by limiting the number of sites and staff expected to perform these very detailed critical tasks. And whenever changes are made, don't assume that they're being followed. You need to have follow-up assessments and a system for periodic site visits, tracers, and gap analyses to make sure that you have ongoing compliance. The support of leadership.
Sorry, John, the slides keep jumping around. Sorry about that.
The support of leadership and the interdisciplinary approach is critical to success. And your policies may need to be revised or created. So the next slide on the priority matrix here. The commitment for change requires system support. The best chance for success comes with group advocacy from health system administration, infection prevention, accreditation, safety management. It's that support and advocacy that needs to exist from the beginning. You're going to need it when it's time to make process or system-wide changes, or when you're faced with a miss or a near-miss incident. And inevitably, there's going to be many things to address, and you can't do everything at once. Yes, some things do lend themselves to a just-do-it approach, whereas many others are going to require education, re-education, resources, approvals, or system-wide changes before they can be undertaken. And you'll want to prioritize the findings based on the highest potential risk. Important is realizing that standards and guidelines take time to develop and update, so keeping in touch with professional organizations and professional societies and standards organizations is important. Similarly, it's important to stay informed as developments occur in between standards and guidelines being published. A few examples from my personal experience where I was able to keep abreast of developments and stay up to date were FDA safety communications, CDC's Health Alert Network. Both of those were as easy as emails dropping into my inbox. As we conclude, we emphasize the need to seek proven information for best practice from standards and guidelines organizations, professional societies, and peer-reviewed literature and research. So that brings us to the last slide and the end of our presentation. We do sincerely thank you for including us. You will see on the last slide our contact information listed. We have a lot of questions that came into the chat that we're not going to be able to get to live, but trust that we will be responding to you. Do reach out if you have any questions or comments or you would like further information. And with that, I'll turn it back to Erica.
Thank you, Marianne and John. So that'll do it for today's webinar. As John said, they'll be able to go ahead and follow up with responses to all of the live questions here. Thank you again to Healthmark for sponsoring today's webinar and to our attendees for joining us today. We hope you enjoy the rest of your day and look forward to having you at future Becker's events.